Hey guys, welcome back. Today we're working on a 2006 RX400h. Now this is a hybrid Lexus with a 3.3 liter engine, and we have a check hybrid message illuminated. Actually, I have a lot of messages illuminated, and this is the second time filming it. My audio stopped halfway through, so we're gonna run through this again. And I want to share some of the frustrations that I'm having with this vehicle and service information. A little bit of backstory: this vehicle came in a couple of years ago with the same code. The code is a p3105, lost communication with battery observation module. It broke down in another town. He took it to the Lexus dealership. The Lexus dealership looked at it. They had it for a couple days, told him that it needed a interior wiring harness. The wiring harness for the battery pack up to the hybrid ECU that's behind the glove box. They said there was some corrosion in it. So the customer came down, asked us if he should just trade it in because it was going to be too expensive to fix. I told him if he's going to trade it in, let me know, and I would buy it for whatever they offered on trade. Because we normally don't see Toyota wiring issues. We don't see corrosion issues unless the vehicle's been flooded. But I believe this was a California car and then a Colorado car, so neither place should it get much corrosion. So he goes and picks up the vehicle and realizes that it runs fine. So of course I didn't end up with it. And he brought it to me. He said, "Can I just pay you to check the wiring?" They said that there was some wiring corrosion by the battery pack. I said, "Yeah, sure." There's no guarantee on what we'll find. At this point, we weren't checking for the symptom. Or the code, because they had cleared the codes. He had given us a reference of what code they had found. I checked the wiring, everything looked good. Drove the vehicle, everything was fine. Not going into low power mode, everything was perfect. I believe he drove it for about 6 or 8 months and the code came back. At that point, I looked at it, still couldn't get anything to act up. I couldn't duplicate the code, and he had driven like 5,000 or 6,000 miles. So since that visit, he has driven 12,000 miles and it's acted up one time. So that's not something that we as technicians are going to be able to duplicate. That's too intermittent for us to solve the issue. Both times he was driving on the highway. Both times it went into low power mode, pulled off the highway. He was able to shut the vehicle off, restart it, check engine light stayed on, but he got his power to come back. So today we're going to look at some service information on that code. So I have 2006 Lexus RX400 pulled up on ALLDATA, and we're going to see what the code set criteria is and what the possibilities are. So P3105, problem in serial communication between battery smart unit and high voltage control ECU. Trouble area wiring harness or connector, HV control unit, battery pack wire, battery smart unit. Typical enabling conditions: the monitor will run whenever the DTCs are not present. And the rest of it's Toyota's intellectual property. They're not going to share that, even with their own technicians. So it's going to give us a quick rundown of the wiring, just a basic communication network here. And it looks like we do have a high and a low, so this is more like a CAN network and not just a single wire serial network or a K line. So we have BTH plus, BTH minus, and it goes from the battery smart unit to the HV control ECU. Now the HV control ECU is behind the glove box, so you can access that without getting close to the high voltage system. And then if you are working with the battery pack anyways, then this battery smart unit is behind the seats. So you're going to want to scope those communication lines and see if there's any issues. Now, they will show you, here's the high voltage ECU behind the glove box, and they show you what the network should look like. Let's see if I can zoom in on that for us. So it looks like a typical CAN network. We have, one switching high, one switching low. I don't know what the bias is on this, if it starts at 2.5 and goes to, half a volt, or if it's a 12 volt square wave. It doesn't really say, but it says that we should, says we should be at 2 volts per division and 500 microseconds on our lab scope. So then it tells us that we should check the harness and connector to the HV control ECU to the battery pack wire. Disconnect those wires. Disconnect these wires so you can't access even with the battery cover on at the back. And they want you to do resistance checks on those communication wires. And it goes on and on and on. Now, I did all this last time it was in here. Everything tested good. He didn't have a problem for 12,000 miles, and then it came back on again. So I started doing some more digging, doing some Googling, and I found a video from Diagnose Dan. And in that video, he mentions a service bulletin. Now, he's mentioning a service bulletin that's from DDTSB, which I believe is his own network of service bulletins. So I don't know if it's an official service bulletin or if it's a service bulletin that he has created, kind of like on Identifix, how they have their Identifix articles. I have checked this code on Identifix and nothing comes up. I've checked it on ProDemand and nothing comes up. And then I also saw a video from Super Mario Auto Diagnostic. Now, he was pulling up service data from, he was working on a Toyota Highlander. His service data didn't look the same as my service data. So I pulled up a Highlander this morning. I looked up a 2006 Toyota Highlander hybrid. Exact same chassis, same power plant, just a different body. This information is different. Let me go back to the top of this page. So we have wiring harness connector, high voltage battery control, battery pack wire, battery smart unit. If we go to the Highlander, we have wiring harness or connector, high voltage control, battery pack wire, battery smart unit, battery cooling blower assembly. Why would that be added to the Toyota one and not to the Lexus one? Well, let's scroll down here a little bit. They give us, most of this is the same information. Step 1 on the Lexus is to inspect the control ECU and look at the network. Let's go back to the Highlander. Procedure 1, same thing. Look at the waveform. And then there is a hint right here. The waveform shown in the illustration varies depending on the contents of communication. Make sure that the battery cooling blower assembly is not operating when measuring the waveform. The operation of the battery cooling assembly can be confirmed by using data list items VMF fan volt 1 through 3. If the values of all data items VMF fan volt 1 through 3 are 0, the battery cooling fan assemblies are not operating. So they want you to check for noise in that communication network with the fans turned off. Next step is to connect your service tool, and they want you to command the blower speed to maximum. Mode number 6. Now that's not to be confused with OBD mode 6. They just want 6 is the highest that it goes to on the scan tool. And we're going to do this here in a minute. And they want you to look at waveform 1 or 2. If you end up with waveform 2, then likely your cooling fans are bad. Now, if I had this information the first time I looked at this vehicle, I could have potentially fixed it. And instead of sending the customer away and him driving for another 12,000 miles until it acted up again, we could have resolved the issue. We were already down to the battery pack. So I'm a little frustrated that the service information differs. So let's go ahead and do this. We are going to scope the communication lines. Now, since I already have the battery cover off, which I'm not going to show all that, there's a lot of safety aspects. You should be trained if you're working on the high voltage system in the back. I'm not saying that a DIY cannot do this job safely, but you got to take a lot of precautions. You have to make sure that you're staying safe. Read all the information in the service manual pertaining to the job and how to do that job safely. So let's go ahead and put the laptop down. We are going to use the Launch Torque 5 today. I believe that's what this one is. This unit has a Oscilloscope and Multimeter built into the VCI. I have the VCI connected to the data link connector. It is wireless. So I plugged it in, it identified the vehicle. We're going to go 16-pin DLC North America. If you're in a different region, on the screen there's going to be a button called Set Area. You're going to click that and pick the area that you're in. By default, these don't come shipped with USA or North America as the region. So the first time I used a launch scan tool and I couldn't communicate to a Toyota, I thought that I had an issue. And it was just that I was not selected to North America. So it has the topology screen. We show CAN 1 and our K line. So we have a serial network and a CAN network. Now that network for our battery observation module is not on this network. That is a direct communication from the high voltage ECU to the battery. Now I'm gonna have a million codes in here. I'm just gonna jump right into the hybrid controller, because that's where our testing is going to be for those cooling fans. And I do have the service plug out. I have the hybrid system disabled, but on this particular vehicle, I can still communicate and command the fans on. And if you look at my voltage at the top, that 13.24, I do have a battery maintainer installed. So before I actuate this, let's go ahead and switch back to our lab scope and see what our signal looks like. So on this unit, even if you're plugged into the data link connector and you want to use the lab scope wirelessly, there's a power button on the top. You hold that power button and you're going to wait for it to connect wirelessly. So that's what we're going to do. And I'm still new to this scan tool, so if I make mistakes in the operation, it's just because, you know, I'm not an Android user and I am new to the launch lab scope. This lab scope seems more like the scientific lab scope to me in operation, and more like what an electrical engineer would use based on the triggering and the setup. It's not quite what I'm used to using, so there's a little bit of a learning curve. But you can do triggers, you can do measurements and all that. So I have channel 1 on 1 volt per division. Now they wanted 2 volts, but it looks like we have an adequate waveform here at 1 volt. Now I'm going to turn on channel 2. Now we need to set that the same. And we have our CAN or communication high and low networks here. Now they look pretty good. If we look back to our service information on the laptop, it looks pretty similar to what they have on waveform number 1. Now their images are a little smaller because they're using that 2 volt per division, and Toyota doesn't normally give the highest resolution images for their known good waveforms. So let's switch tabs here. We're going to go back to our the launch app for scan tool. We're going to go to actuation test. Drive the battery cooling fan. Now it said that we should go to test mode number 6. So we'll hit number 6. We're going to switch back. And our waveform is getting pretty nasty. I can hear the fans ramping up in the back. And that is a terrible, terrible waveform. Now, before I took this all apart and I had the service plug still installed and I wasn't even monitoring this data, I could get the fault code to replicate just by commanding those cooling fans to number 6. So that was my confirmation that, okay, this is the issue they're having. And that's why it's only doing it on the highway. They're under heavier load. They're running those batteries and those cooling fans ramp up. And once they get to a certain level, and it may be that level 5 will cause it if the fans run long enough. But maybe, they're pulling a hill and the fans ramp up to number 6, kick on, start cooling that battery pack down, and cause so much noise on this communication network that it causes the system to have an error, because this is a pretty nasty waveform. So let's go ahead and switch tabs. I'm going to turn those off. So here's what I'm going to do. I'm going to plug in the new cooling fans, and then we're going to run this same test again and see what the difference is between the old fans and the new fans. So I now have the new fans plugged in. Now I will tell you, if you're running the fans and you unplug one of them, it will shut all the fans down. You'll have to cycle the key after you plug a fan back in. If it sees a fan that's not working, it deactivates the whole system. So our signal looks good. Go to fan mode number 6. Go back to our communication lines. We see a tiny bit of noise. The fans are still ramping up. And the nice thing is that I've noticed, if the fans stop running for some reason, you don't have to turn the actuation test on again. You can just cycle the key real quick and it'll re-enable the fans. So I can hear them ramping up. Now it is quite loud because I have the battery cover off. It sounds like a little tornado back there, vacuum cleaner. But those fans are getting pretty loud. They're all the way on high speed now, and our communication network looks great. Let's go ahead and shut those off. Now, last night I spent quite a bit of time, with the amp clamp, with the voltage readings, going through these fans, looking at them. They are a 4-wire fan. They have a power ground, they have a command signal, and they have a monitor signal. So the command signal comes from the battery smart unit there, and the monitor signal actually goes all the way up to the high voltage ECU behind the glove box, or the hybrid control unit. And I didn't see any abnormal signals. I didn't see any signals that were different from one fan to the other fan. All of the fans had very, very noisy power signals and very noisy ground signals. Now, the new fans do not. So I don't know if the fans were just pulling so much current, they were overloading the battery ECU. They have a common ground, they have a common power source, and then there's 3 different command lines coming from that computer to command those fans on. Now, I don't know under normal circumstances if the controller will run each fan at a different rate depending on if that battery pack that fan is cooling has higher temperature. The center battery pack is quite small. It's about half the size of the 2 outer packs, but it has the same size fan. But it does have a smaller inlet. So maybe they just ramp them all up together and turn them all down together, but they also may do independent control. There's not a lot of information in the service manual. Now, Launch did send me this scan tool for testing. There are a few other functions that we'll get into in later videos. It does have a multimeter built in, so I'm sure we'll find some uses for that. And I'll use it until they want me to send it back, and I'll let you guys know, what I feel about it. So far, it seems like a capable scan tool. There is a little bit of learning curve for the oscilloscope and just the operation of it. You can connect this with a USB cord to the VCI as well. And I was having some issues with that, but once I switched to a different cord, I probably grabbed a bad cord. Once I switched to a different cord, those problems resolved. And then I didn't even realize that I could do the lab scope wirelessly until a couple of days ago. And, that seems to have, cleared up some of the issues I was having. So if you have any questions on the Launch scan tool, or if you have any testing that you want me to do, then let me know and I'll try to get that covered for you. And then if you have any questions or comments on the vehicle, let me know. Do you guys find it frustrating when service information isn't adequate? Because I find it terribly frustrating. Speaking of service information, I had a 2010 Dodge 5500 in here the other day, and it was setting a code for the transmission pressure sensor or linear control solenoid or something like that. It's a fire truck, so every once in a while when they're driving it would go into limp mode. It wouldn't disable them, but it would shift bad. It would reduce the power a little bit. So definitely a concern, Because it's a 5500, the information was very limited in all data pro-demand identifix. So I paid for a factory subscription. In the wiring diagram, it says that the wiring goes through the C130 connector. I couldn't find a pinout. The pinout was missing. Every time you click on the pinout, it would take you to the wrong connector. So I submitted a help request for that. And it took them a couple days before they sent me a pinout. And by then I already figured it out. I just manually traced all the wires through the connector without the pinout. But they actually sent me a diagram for 2009 that buried in service information had that same connector under a different name, and the pinout was correct. And they told me that they may or may not be able to fix the service information because everything 2009 and older had been archived. Some of 2010 vehicles had already been archived. What's crazy to me is that no technician reported the issue in the service information in the last 13 years. So you're telling me not a single dealer technician looked for the pinout of that connector in the service information? It just baffles me. Even a factory paid subscription, and I was still having trouble finding accurate service information, which, as we know, the aftermarket service information is built off of the factory service information. So if the factory has it wrong, the aftermarket is most likely going to be wrong. Okay, that's my rant. Done and over with that. So I'm going to install these new cooling fans, reassemble everything, and clear all the codes, run the fans, make sure the codes don't set. Everything should be good. We can release this back to the customer and he shouldn't have any issues. While it's apart, I'm going to clean out the hybrid cooling fan inlet vents. They looked pretty clean, but I'll blow them out with air. I know that my Highlander, I have a 2007 Highlander hybrid. I probably need to pull those vents off and clean them because Valerie hauls the dogs in our Highlander and there's dog hair everywhere, and I'm sure those vents are getting plugged up. I've cleaned them once before, but I'm sure it's time to clean them again. So I'll likely post a video of that, and I kind of want to do the same test on my personal vehicle because I don't want to enter a low power mode because I often take that vehicle whenever we go on trips. If we're going cross country, I don't want to have an issue with low power. So like I said, questions, comments, put those down below. If you like this video, give it a thumbs up. You want to see more videos like this, repair videos, diagnostic videos, random videos, live streams, subscribe, click the bell. Thanks for watching, and I'll see you next time.